you might want to do is do a search for Mr. Parsons' math page, which would take you to here. All right? And if you come over here to the links on the left, for your class, it's integrated 3. So if you would miss a day or anything like that, the stuff is up in here. You just click on integrated 3 for this right here. And so, for instance, if you would miss like notes on Tuesday, kind of tells you that the notes are here if you want to watch it or catch it that way, you can do that. But if you do a search for Mr. Parsons' math page, there's actually 2 pages that come up. Okay? Make sure you pick the one that looks like, well, it's got like a graph. It's got like this goofy graph right into this wonderful point right here.
Is the other one yours too?
Yeah, the other one's a way old one. I think it's way old. I just need to eliminate that site, so this is the only one that comes up, okay? But all that stuff is in there. If you miss a day, feel free to go get that stuff, okay? Good deal?
Yep.
All right, let's rock. Kids, we're going to start talking about what's known as two-way tables. We're going to talk about some conditional probabilities, but there's going to be a lot of terms today, and we need to make sure we understand what the terms are. Now, I think we kind of touched on this a little bit last year. If you were with me in Integrated 1 last year, we touched on this a little bit last year, and I think that this should make a lot of sense. I will tell you right now, you're definitely going to want a calculator. Okay?
My phone?
Yeah, I don't care. That's fine. Just be understanding that if an administrator walks in and takes it from you, then I'm not responsible. Okay? Honestly, I think there's... well, yeah, cut you some slack, huh?
I don't see why they took phones when I study.
Yeah, that's good.
I don't make the rules. I just work here. So, yeah.
I get it past numbers.
Yeah. You okay?
Hey, good. It's my book.
Okay. You fill it out and I'll sign it. Back up on my sign it and you fill it out.
Either way,
Harley, dude.
you can go anywhere now. That's a
Yeah, that's on green card, right?
See you in Vegas.
Las Vegas. Imagine.
All right.
I don't get it, guys.
All right, kids, here we go. What we're going to start looking at today, kids, is kind of a spin-off of what I've been doing, kind of some conditional probability things, or some dependent events, if you will. And one way to easily recognize what those conditional probabilities look like for dependent events is to use what's known as two-way tables. So the question we're trying to answer today is, how do you construct and interpret a two-way table? Okay, and two-way tables might come up like this. They might ask the question in here, what do I have? Mostly sophomores and freshmen? Okay, so I might say this. How many sophomores are planning on going to college? And some sophomores would raise their hand. And then I would say, how many sophomores are planning to go into the workforce? And some sophomores might raise their hand. Okay? Then I might turn around and say, how many freshmen are planning on going to college? Some might raise their hand. And then I might say, how many freshmen are planning on going into the workforce? Okay? So we're talking about either going to college or into the workforce, and we're comparing two groups, which are freshmen and sophomores. So we kind of are comparing two categories with two other categories, and we want to see what those numbers look like. So we might say, given that you're a freshman, what's the probability you're going into the workforce? Or you might say, given everybody, what's the probability that everybody's going into the workforce? Okay? So we're going to look at some conditions like saying, what if the person's a freshman? Then what's the probability they're going?
Oh yeah, given then statements.
Given this, then what? Yep, exactly. So our goals today, and when we revisit this, is first of all, we have to make some two-way tables. We're going to find what's known as relative and conditional relative frequencies. And we're going to use conditional relative frequencies to find, this is a biggie right here, to find what's known as conditional probabilities. All right? This will be a biggie for us today. So we have a lot of vocab here, and I'm not sure I'm going to get to many examples. I think what I'm going to do is I'm going to write down a two-way table. Well, you'll see one here in a second. Okay? But a two-way table. How about a volunteer to read that for me, please?
A two-way table is a frequency table that displays data collected from one source that belong to two different categories.
Okay, so data from a source that belongs to two different categories. So if I jump ahead here, I'm going to jump ahead to this page right here. Okay? This would be considered a two-way table. All right?
Oh, I know.
We're comparing what classes here, kids?
Junior and senior.
Juniors and seniors, and some kids that either qualify for something or do not qualify. So over here in the notes, I'm just going to write down here, what's a two-way table? I'm just going to write down C example 1, okay? C example 1. See example number 1 there, okay? All right, so joint frequency. Joint frequency is simply each what, kids? Okay, each entry in the table is called a joint frequency. So anytime we have a number in there, it's just called the joint frequency. So joint frequencies typically, I'm gonna highlight this table a little bit. Is that okay? All right. Right here in this example 1, the joint frequencies are going to be the values that are in here. Okay. Those numbers in there that compare the categories, junior, senior, with qualify and don't qualify, are going to be called your joint frequencies. They're just going to be numbers that are put in here. So if I jumped ahead to this table right here, your joint frequencies would be all these values right in here. Okay.
See example 4.
Okay. Maybe. Actually, I think there's a better one. Maybe example 5 would also work, and we'll get there with that. But your joint frequencies are going to be just the numbers that they put in here. Now notice, joint frequencies are not the what?
Totals.
They are not the totals. They're the numbers that are going to help you come up with the what? Okay, so the joint frequencies are the numbers listed in there. They help you come up with the totals. So back to the vocab here. All right, joint frequency is the entry in the table called, each entry is a joint frequency. Marginal frequency then, says it's the sums of the what? Rows and, okay, so I just call these the, yep. Marginal frequencies then are simply the,
Because they're in the margins.
yeah, they're the totals. Whoops, I've got that in the wrong box. Whoops. These are simply the totals. Yep. Okay. All right, then we get into some things, and this is where I think that things are important to understand. It's kind of, I'll see if we can't make sense out of this here, but these are kind of difficult for kids for whatever reason. So when you see these, joint relative frequency, marginal relative frequency, conditional relative frequency, you might want to refer back to the notes. So I'm just going to put down that, you know what, I think these are pretty darn important right here, okay? Those are pretty important. So make sure you see relative frequencies. You might want to refer back to this. And we're going to look at a lot of examples that differentiate the definitions, but I want to make sure you don't get confused because it's very easy for kids to confuse these terms as we're looking through these, okay? All right, so how about joint relative frequency? Who wants to read that first? Michael, go ahead.
Boy, a joint relative frequency is a ratio of a frequency that is not in the total row or the total column to the total number of values or observations.
Okay, so we're always comparing. It's not in a row and it's not in a column, okay? But what this joint relative frequency does, kids, is it compares like everything to the, oops, I didn't want to do that. I'm going to write down compares your joint frequencies to the overall total. It's going to compare your joint frequencies to the overall total. And what I mean by that is this. Compares your joint frequency to the overall total. The overall total is going to be the sum of all joint frequencies. So let's just say this. We have some freshmen and some sophomores in here, okay? Let's just say this. Maybe you like, I don't know, let's just assume Pepsi or Coke. Is that fair?
Root beer.
Okay.
That's disgusting.
All right, I'll put up here root beer and I'll put up here I don't know. Which one? Okay, if you had a choice between right here, here's the deal. How many of you are freshmen in here? Show them hi, freshmen.
3.
There's 3 of you. How many of you would take the root beer? Michael would, so I've got 1. So that means that there's 2 freshmen that are going to take the Dr. Pepper. Okay, sophomores. How many sophomores would take the root beer? 1, 2, 3, 4, 5. 5 of you. How many would take the Dr. Pepper? 1, 2, 3, 4, 5, 6, 7. Okay? So what I'm talking about right here, kids, is this. The freshman row would total up to what here, kids?
3.
Okay? This row would total up to what? Well, 12. Okay? But the deal is this, kids. How many total people are in this right here?
15.
Okay, we're not comparing it just relative to freshmen or relative to seniors. We're saying a joint relative frequency is basically saying there's 2 out of how many completely? 15. This down here is going to be this number in the bottom right is always going to be like your overall total. Okay? So we're going to have some row totals. We're going to have some column totals like this. But the overall total, how many total people am I talking about? 15. We're talking about freshmen and sophomores combined. Okay? Does that make sense? So a joint relative frequency is always comparing your joint frequencies to an overall total. Not a marginal total and not a column total. Or a row total or column total. Okay? And we'll look at an example. Now your marginal relative frequency, a marginal relative frequency is the sum of the what? Joint relative frequencies. So to find your marginal relative frequencies, it's just the sum of the joint relative frequencies, and I'll show you how that works in a little bit. Marginal relative frequencies, kids, they're like a percent. Whoops. Okay, they're like I didn't want to do that. They are like a percent. Okay, and then a conditional relative frequency, kids. A conditional relative frequency is the ratio of a joint relative frequency to the marginal relative frequency. Okay, and basically, this is like comparing a joint frequency to a row or column total. Not an overall total, but a row or column total. Okay? That's why they call this, what's the word here, kids? Conditional. Might say, given the person is a freshman. Listen to what I say. Given the person is a freshman. Okay, how many people were freshmen? What's the probability that a person is going to choose the Dr. Pepper? Well, you would say 2 out of what? 3. Now, if I was talking the joint relative frequency, it would have been 2 out of what? 15. Okay. Makes sense to you? All right, so let's look at some examples here. Conditional probability, we had that in the last section, so I don't really need to go over that. Conditional probability is just like a probability of, you write it as a probability of event B happening. How do you read this again, kids?
Probability B given A.
Yep, given that A happens, exactly. Okay. All right, so vocab-wise, do you have what you need there, first of all? Okay, let's move on this here, okay? So at the very top of this right here, example 1, how to make a two-way table. Volunteer to read example 1, please. Thanks, Michael.
There are 16 juniors and 24 seniors on a debate team. Of these, 7 juniors and 19 seniors qualify for a state debate competition. Organize this information in a two-way table. Then find and interpret the marginal frequency.
Okay, so the marginal frequencies, we'll talk about what that means here, but kids, let's just talk about this, okay? How many total juniors are there?
16.
Okay, so in the junior right here, what could I put over here for the total number of juniors? 16. So where can I put that 24 then?
Below 16.
Right? Okay, so my 24 would go right there. All right, we all agree where I've got the junior and senior total in the right spots? Okay, so now it says of these, 7 juniors and 19 seniors do what? Okay, so where's that 7 gonna go?
The junior qualifies.
Okay, so right up here, the juniors are gonna be 7 that did qualify, and then how many seniors qualified? 19. All right. It says organize this information in a two-way table, then find and interpret the marginal frequencies. Well, let's first of all get all the values figured out here. Those are the ones that we could definitely put in, but now are there values we could figure out?
Did not qualify for juniors would be 9.
How do you know that?
Because
And subtract.
there's
Yeah.
they're missing from the.
Exactly. 7 juniors qualified for debate, but there were how many total juniors?
16.
So how many did not qualify?
9.
9. Okay. How many seniors qualified? 19 out of?
24.
So meaning the number that didn't qualify would be? All right, so let's just check this out. 7 and 19 adds up to what?
27.
14.
Okay, and I'm going to put this 40 in a different color here. Okay. This 40 is like my overall total. So how many kids are we talking about totally?
40.
Okay, this number right down here. This number right down here, kids. That's my overall total. Okay? That's not a marginal total. This is an overall total. So I've got like column totals. What's the column? What's the first column total? What's the second column total? Notice what do 26 and 14 add up to? 40. What's my row total up here? What's my row total here? What does 16 and 24 add up to? Okay, so here's what we get going on right here, kids. It says interpret the what, kids? We better go talk and figure out what marginal frequencies even mean again. Okay, somebody read marginal frequency again then for me.
The sums of the rows and columns are called marginal frequencies.
Okay, so let's talk about what the marginal frequencies are. Marginal frequencies are the totals of the columns and the what? All right, so let's talk about what this means. Okay, this is a row total. All right, so this row total of 16 means that there are 16 what? Juniors. Okay, what's this marginal frequency of 24 mean?
Seniors.
That was the number of
Total seniors.
seniors. Okay, this is an overall total. Is it okay if I write OT down here for overall total?
Overtime?
No, overall total. Okay, marginal frequencies are also figured by totals in columns right here. So what is this value of 26 representing?
The amount of people that qualified.
Okay, so the number that qualified, right? What's the last marginal frequency we haven't discussed yet?
The total that did not qualify.
And what number is that?
14.
So there's 14 that did not qualify.
Isn't that just suppressing they didn't qualify?
Did not qualify, all right?
What are they qualifying for? Let's make
Looks like debate team.
Oh, yes, we love it.
Okay. So let's do this. Let's figure out what's going on here in example 2 where we start finding joint and what?
More
Marginal, and then the word right behind that is what?
relative.
Relative frequencies. This is where things get kind of tough for kids, okay? This is where things get kind of tough for kids. But if you can just remember that joint and marginal relative frequencies here, kids, these are all based
On row and column.
on overall totals. These are based on overall totals. So here's what they're saying. It says use the debate competition information in example 1 to make a two-way table that shows the joint and marginal relative frequencies. Joint and marginal relative frequencies are simply saying turn stuff into, anybody have a guess what the next word is? Percent, you bet. Okay, and we're probably going to turn it into a decimal. They leave them as a decimal. They don't really turn them to a percent, but it's like turning it to a percent. So here's how I want this to work, kids. Take a look at that table up here, and I need some volunteers that are going to help crunch some numbers for me. How many qualifying juniors were there? 7 out of an overall total of how many kids? So what we're going to say is this. These joint relative frequencies are going to be the 4 boxes right up here, and then the marginal relative frequencies are going to be in the totals right here. So this is going to be 7 out of,
40,
okay, somebody divide that out for me.
1.7.
Ah!
I mean, 0.17.
0.175, okay. Let's call it 0.175. So they typically round to the nearest. I don't want to. Let's call it 0.175. What the heck? Let's get exact here.
75.
Oh, isn't that just so beautiful?
No, it's 175.
It doesn't matter.
Yeah,
It's
he's like,
75.
oh, that's just so beautiful.
He put a smiley face next to it. Put a smiley
And
face
some
next to
thumbs
it.
up, guys.
You better put a smiley
Okay.
face next to it.
And then he's like, oh, you get a Jolly Rancher.
Oh yeah, I
You
forgot
can
it.
come and listen.
I think it's fine.
Guys, let's
bribe
all get
us to
along.
stay away. I think it's fine.
I love how he loves.
I obsess. Well, you know what my love is? Sour Patch Kids. So
Who draws Sour Patch Kids about?
I can't do that. It's just not a number.
Just
It's
like
just,
throw Sour Patch Kids.
I just like them in my belly.
How many
That's
Sour
not-
Patch Kids is in a
Just
big
like
bag?
the 2 times bigger. or
Carson,
not
just
2
make
times
every
bigger.
every single one of your story
Actually,
problems.
they're 8 times bigger.
Carson, just make
We
every one of
talked
your
about
story
this
problems
last
about
What's the Logan?
Sour Patch Kids.
Jolly Ranchers are cute.
We could. Okay. Hey, how many senior students qualified? So if I wanted to find a joint relative frequency there, that would compare the total number of seniors that qualified of how many total kids? 19 out of 40. Okay. Run that for me.
475.
19.475.
Wow, you're making my day so happy.
Okay, good. I'm glad you're happy. Somebody do the 9 divided by 40.
I just 0.225.
0.225. Okay, somebody do the 5 divided by 40. 0.125. Okay, now I want to show you something right here. The numbers in black right here, the numbers in black are I'm gonna watch what I write. These are gonna be considered J, R, F. What's that stands for? Joint relative frequencies. Okay? We took the joint frequencies, the numbers from the data. We call them joint frequencies because we're joining how many juniors qualified. We're comparing 2 categories. How many juniors qualified? Qualifying juniors were the 2 categories we combined or adjoined them. That's why they're called a joint frequency. Now, I'm going to put the marginal frequencies in here, and this is the easiest thing to do. Once you know the joint relative frequencies, the marginal relative frequencies are very easy to find, kids. All you're simply going to do is take 0.175 plus 0.475 down here, or you could have done 26 over what, kids? 26 out of 40. What's that equal?
0.65.
0.65. Okay, when you add them up, it's 0.65. All right. If you wanted to do the number of kids that did not qualify, it would simply be 14 out of what, kids?
40.35.
Okay, the word relative just means turn everything basically into a what, kids? A percent. It basically means turn that into a percent. Okay, well, let's do it for the rows then. All right, 16 of the 40 were juniors. Oh, and by the way, what's 0.225 and 0.125 add up to? Let's not even do that. Let's just add across here. So go 0.175 plus 0.225 here. Yeah, 0.4. I like that. Total would be 0.4. I like that, I guess. I'm sorry.
Matt, how would you
Add this one up right here for seniors. 0.6.
They should both equal 1.
What's 0.4 and 0.6 add up
Oh my
to?
gosh. The overall total is always 1 because of percents.
Because it's 100%. We're talking about 100% of everybody.
You gotta
Yep.
equal
Your marginal relative frequencies will always add up to what value down here then, kids? 1. Do they add up to 1?
Wow.
Means we've done something correctly then. Okay.
That's all we're doing.
Pretty much, we're going to start looking at conditional relative frequencies, but if we talk about joint relative frequencies and marginal relative frequencies, it's based on what, kids?
Overall.
Overall totals, okay? All right, let me know when you have that down. Are we good, kiddos?
Yes, sir.
All right, let's move on to the next page here. And on the next page, we're all good here?
Yeah.
Okay, on the next page, right here. Top of the next page, example 3. Example 3 says conditional relative frequencies. Okay, so we're going to use that data, again, from example 1 to make a two-way table, and we're going to Find the conditional relative frequencies based on the what?
Road total.
Okay, so the row totals were here. So here's the deal. We need to get those values again. So I'm going to write down this. Use a debate competition from example 1 to make a two-way table that shows the conditional relative frequency for the row totals. Okay, how many juniors qualified again?
7,
7, right? So there were 7 here. What was this? 9
Yeah.
and 16? And then right here, number of seniors, what was that?
19 and 5.
19, 5, and
24.
okay, so now kids, what they're saying is this. They're saying we want what's known as conditional relative frequencies. And what a conditional relative frequency is simply saying is this. We're basing it on the rows. Row 1 is what, kids? Well, row 1 is what category, I guess? Juniors, okay? We're kind of saying we're giving you the condition that this person that we're talking about is a junior. So what we're kind of saying is what's the probability, given that the kid was a junior, what's the probability they qualified? Or what's the relative frequency that they qualified? So when we do conditional relative frequencies, it's not based on the overall total. It's based on row or column totals. So as an example, kids, if I'm talking about rows, we're talking about the idea that, ooh, this person's definitely a junior. What's the probability they qualified? Well, how many total kids were juniors, kids?
16.
And how many qualified? So we're not doing 7 out of 40 anymore. We're doing 7 out of 16. So somebody run 7 divided 16 and tell me what that conditional relative frequency is as a decimal.
0.4375.
So 0.44 about, we'll round to.
Sure.
Okay, 0.44. Okay.
I bet the other one is 0.66.
Okay, I was going to go 0.56, but next one, that would be 9 out of what?
Wait. Oh, it would be 0.56. What is it? I don't know.
It is 9
Oh, what is it?
repeated
0.56.
equal 1.
It's 0.56.
0.56?
Oh, it is 0.56. not 0.66.
Actually, it's 0.5625, but we'll go nearest hundredth, 0.56 here. Now, kids, conditional relative frequencies say, what's 0.44 and 0.56 add up to again?
What?
1. And it's only going to be that way when we're talking about what kind of relative frequency? Because those are based on totals from the row or the columns, not the overall total here, okay? So you guys tell me what this is going to be down here. What divided by what for this, given that the person's a senior? 19 over 24.
It's going to be 0.56 again.
Point.
Because don't have to add up to 1.
Well, not necessarily, because this total's 26 up and down now. 7 and 8. Okay, it makes sense. Okay, so 19 and divided by 24. What is that, kids?
Oh, Michael, you got your good.
0.79 and 1.666.
So 7, 9. So given that the person's a senior, what's the chance that they qualified? There was a 79% chance. Under the condition that this person was what, though? A senior. Okay, so what's this going to make 5 out of 24 be?
Hopefully something's good.
Well, that would be 0.21.
19%.
0.21, because 79 and 21% are going to have to add up to 100% of the seniors. Okay? So conditional relative frequency is the only frequency that's not based on the what?
The
Overall.
overall.
Okay, and that's the one that's kind of goofy. All right?
I like the overall one.
I do too. The overall one's a lot easier because you know everything just adds up nicely. Conditional relative frequencies are a bit goofy at times. All right? So let's talk here, kids. It says a store surveys customers of different ages. The survey asks whether they would like to see a store expand its toy department. The results given are as a joint relative frequency. Okay? So this is all about the overall totals. If you took all those numbers right there and added them up, what would you expect them to add up to?
1.
1. Okay. In fact, I'm gonna make a little chart down here. I'm gonna put my little box down here. I'm gonna say that that's 1. I hope it's 1.
What if it's not?
Well, let's just check. Wouldn't this add up to 0.36 down here? And wouldn't this add up to point? Ooh, 0.23? Wouldn't this add up to 0.41? Let's see, 59% and 41%, that's 1. Yep, that works. 27 and 23, this is 0.56 up here. When I add them up, when I add all these up, I get 0.35 and 9 is 0.44. I think they all add up, don't they?
Legendary.
Gnarly, man. So cool. So, here's the deal. It says, what is the probability in Part A that a randomly selected customer whose age is what?
Between 10 and 20.
So we're only talking about the people for Part A. For Part A, we are only talking about the people where?
Middle.
Okay, we're not talking about anybody else. We're only talking about that row right there. Or I'm sorry, that column right there. People 10 to 20. Okay? The people that are 10 to 20. That's all we're talking about. Okay? How many would not like to see the toy department expanded? Well, what percent up there said they don't want to see the toy department expanded? 17%, right? But the 10 through 20-year-olds only make up what percent of the whole population? Okay, so we're saying given that a person's 10 through 20, it's like saying 0.17 out of 0.23.
Wouldn't you multiply?
No, it would be a division problem, okay? They want, because it's a, what's the word? So it's going to be a ratio, right, or division. So in this one right here, 0.17 said no. Ah, shoot, I didn't want to do that. 0.17 said no, but what percent were between 10 to 20, kids? 0.23. So somebody run 0.17 divided by 0.23. 739, so approximately 0.739, or I'm going to write this way, 73.9% of people age, what age are we considering here? 10 to 20, say what? Well, they say no. We're not comparing the whole population. We're only looking at the part of the population that's between age 10 and 20.
They
Okay?
could have got some bigger age group.
All right. You guys try Part B on your own. See what you get. Part B says, what's the probability that a randomly selected customer who would like to see the toy store department expanded is younger than 10? So basically, these are all the people that are saying what?
No, or yes.
Yes. See if you can get Part B. What divided by what? Part B.
Kids love toys.
I love toys. I can't wait till Christmas. You guys have a Nintendo Switch?
No.
Is it worth it?
Same
Is it
on
cool?
this end.
They didn't have any good Black Friday deals. I was gonna get them for Black Friday, and
Were ya?
none of the deals
Yeah,
were that good.
That's wrong.
I'm curious because I got one for my girls for Christmas, so I'm really ready.
You
They
mean
really are great.
You need Santa got them?
Yeah, Santa's
Santa?
great.
No. Santa Claus hopefully Santa Claus brings me a 2019 red Chevrolet Silverado Z71.
Is he going to?
I don't know.
You don't need one of those.
I have it on my list though.
What's yours right now?
You should buy, you should buy a car. 'Cause
I'm having a hard
some
time with the new
people
body
get
style
that
on
done
Chevys.
better.
They're,
Yeah, you don't like
I
them
don't
as
like
much.
them very much.
Yeah.
I'm having a hard time.
Ford all the way.
You know, it's funny you say that, Adam, because like when my favorite race car driver is Ryan Newman. Not that there's any NASCAR fans in here like me, but Ryan Newman drove a Dodge when I was driving a Dodge Ram pickup, and then he switched over to Chevrolet about the same time I switched into a Chevrolet truck.
Did you just get a Ford?
So well, listen to the story. I'm not done with the story. So about midway through his Chevrolet run, he switched to a different team, to a different Chevrolet. So I traded one Chevrolet for another Chevrolet. Okay, I guess where Ryan Newman's going next year. Going over to a Ford next year.
He knows
That's
big
like
yard.
driving a Ford to school.
Boy, I don't know if I can follow that.
Yeah, you
Boy,
can.
if I ever drove around in a Ford, that would be like the. You guys would never let me hear the end of it, would you?
Like a Ford
No,
Larry.
I would agree. It'd be like about time.
Oh, come on. I like to razz you guys up. I don't think anybody really makes a bad pickup anymore. So I think they're all pretty good.
Nissan, man.
I will say this.
Toyota
I will say this. I think the Fords have a neat looking truck. I think they're pretty cool. So,
F-250.
Hey,
are
bring
pretty
it back
sexy.
to Ford Ranger.
are they really?
And the Ford Bronco.
Yeah, the Ford
Cool.
Bronco, but it
The
looks
Bronco. Yeah, I saw that.
Yeah.
I did see that. All right, so let's get back to this so we can finish this up. Part B, what's the probability that a randomly selected customer who would like to see the toy department expanded is younger? We're going under the assumption that the person is saying what here, kids?
They say yeah.
They say yes. So what's the decimal for this row total for yes? What is that decimal over here? 0.56. And of the 0.56 in that row, how many were younger than 10? 0.27. So to get that probability, you would do what, kids? Well, 0.27 divided by,
Huh?
So 0.48.
yep. So again, we're assuming that we're only working with this row right here because we're assuming they're going to say yes. So this is the value that said yes, and of that value that said yes, how many were younger than 10? Okay, so this would be 0.27 divided by 0.56, which is about... Okay, again, this is all conditional. This is all conditional. We're in a certain row. We're not using the overall total anymore. We're using row totals or column totals. So you said 48% with this? 48.2? How many had 48.2 there? I'm just curious.
I had 75.
Okay.
Of course you did.
Did you actually?
Yeah, I actually did you get that or did you just
No, I got it too.
that?
No, if you
Both
do
made
from
If you
the
do the 0.27 divided by 0.3.
It says determine whether replying yes and being younger than 10 are independent events. Okay? Take a look at this. Younger than 10, what's that total up to? 36% of the total population, right? Okay? So if stuff is dependent, that means the sample spaces would be different. If they're independent, the sample space size would be the same. So 36% of all these people surveyed are in the younger than 10. But they said compare that to the people saying yes. What percent of people are saying yes? Is 56% of the population the same or different from 36% of the population? They're very different, right? So since those two sample spaces or two sizes of population are different, is this an independent event or dependent event? It's dependent, right? Because the sample space, 36% of the population is not the same number as 56% of the population, right? They're different sizes. So you're choosing from different groups each time, different sizes of group. That means that becomes not an independent event. So not independent, and here's why. Not independent, and here's why. Because 0.56 does not equal what? 0.36. Now, if the sizes were the same, then what? Then it would have been independent. Okay? All right, so one last example here. We'll talk our way through one last example. I will let you know I did send out an online page. Tomorrow's going to be a work day for you guys. So be good there. Okay? You're going to be gone tomorrow? Yeah, I should have it printed after 5th hour.
Hey,
Sound good? Okay. All right, last example right here. Comparing conditional probabilities, kids. It says an airline company strives not to lose luggage for passengers. Okay? A manager at the company randomly selects 3 flights to check on lost luggage. It says at the end of each day, the manager determines whether or not there was a luggage lost on the flight that day. Okay? Table shows the findings. Which flight does the best at not losing luggage? Well, kids, how many of the cases was luggage not lost here on flight 1? 3 out of a total what?
That's bad.
These people are trash.
Yeah, how hard is it to just keep track of the luggage?
Obviously, it's pretty difficult. 3 out of what, kids?
3 out of 9.
no.
What?
we gotta
Parsons.
That's not
They
appropriate.
must be flying Atlantic or something.
No, Malaysia. Because there's no plane.
That's not cool. Flight number 2. Help me out about flight number 2, kids.
5 out of 14.
I didn't.
They lost 5 out of 14 flights. How about flight number 3? Now, guys, when we're comparing conditional relative frequencies right here, which flight appears to have the best record for not losing luggage?
Flight 2.
Flight 2.
Like 3.
Okay, we're talking about not losing luggage, which means we want the percent for not losing luggage to be high or low.
That's 2.
Okay.
What?
So how many didn't lose luggage here? 13.
That would be
3 of them didn't, right? What percent is that?
the highest percent.
Okay, or I could go the other way here, kids. How many did lose luggage? 10 out of what?
23% lost luggage. Wait, didn't lose it. I don't know. I just got 23%.
Okay, let's just go this way. Go 10 out of 13 for me.
77.
Okay, 77% lost. How about 9 out of 14 was lost? 60 what? This flight number 3. Yee. 13 flights, lost luggage 12 times. Okay. 92%. Which company is going to pride itself on not losing luggage? Flight 2. Okay, flight number 2.
Really, none of them should.
None of them should, because they're all losing over half the time, right? But which one's the least? Flight 2. Okay. Flight 2.
Most likely some luggage is going to get lost.
That's why I drive. And I still lose luggage when I drive.
4 times.
I know.